A web attack is a type of cyber attack that targets any vulnerabilities in web browsers or applications. They can be used to steal data, gain unauthorized access, or disrupt the browser services. Web security is extremely important since all info from banks, hospitals, and personal data are transmitted via the internet. The assets at risk include user data, which are passwords or credit cards, server-side databases, session tokens, and admin control panels. During web attacks, the goals of the attackers are data theft, website defacement, full control of back-end systems, and financial gain. Common types of web attacks include cross-site scripting, which involves injecting malicious JavaScript on legitimate or trusted websites. Cross-site request forgery, which tricks users into submitting unwanted actions. SQL injection, which includes manipulating database queries. Broken authentication, which involves weak login/session management. And clickjacking, which involves tricking users into clicking hidden elements. Cross-site scripting allows attackers to inject JavaScript into websites that other users visit. A common example is injecting a script through a comment field, like the one below. This allows the attacker to steal user cookies, hijack user sessions, deface websites, or redirect users to malicious sites.
Cross-site request forgery tricks a logged-in user's browser into sending an unwanted request to a web app. Since the user is already authenticated, the app executes the action. For example, let's say a user logs into their banking site. They then visit a malicious site with a hidden API request. Since the user is still in an active session on the banking site, the app thinks it is a legitimate request and executes it. This can lead to funds being transferred, emails changed, or passwords reset.
A SQL injection is where an attacker inserts malicious SQL into a form field to access or alter the database. Below is an example of vulnerable code with a query that will logically return true, allowing the attacker to gain access.
To show a case of SQL injection using a Flask framework. So we also are using a SQLite database to manage our user logins, and this is just a simple script to generate a website that uses SQLite database to log in their users. So we can see in here in our init DB class, we're initializing our database, connecting to the SQLite database, we're creating a users table, and we're creating a login with username admin and admin pass as password. And then we have another helper function to get our database connection, where we try to get an existing database connection from Flask, and if we don't get a connection, we create one. This is just to close the connection, so we're making sure our memory is still intact. And then we have a login function where this is for the vulnerable login. This is where the SQL injection comes into play. So we can see here we get our username and password from the user input, and we build a SQL query by directly inserting this input. So we can see select star from users, where username equals our username and password equals our user's password. Then we just check if the user is valid. If they are, we welcome them. If not, we tell them that they failed. And then this function is for the secure login, where we use a parameterized query rather than directly injecting username and password in here. So you can see we have select star from users, where username equals question mark and password equals question mark. And our two question marks are username and password. And again, we check if the user is valid. And then we have our main function here, which just calls or just initializes our DB, and then we run our servers. So if we come over to here, this is the insecure login. So if I go and say I do admin and admin pass, that works because that's a valid username. If I do admin and not admin pass, you can see it fails. But since we're directly putting username and password into the SQL query, we can do something like this. And we get added in. We're allowed to log in. So the logic behind this, if we come back to our code, is in our insecure login, we have select star from users where username equals this and password equals this. So if we were to write this in, we would get where username equals admin here, and then our password would equal this chunk that we had. I'm just going to copy it so I don't get it wrong. And so if we directly replace this, basically this is saying, hey, check where the username equals this and the password equals nothing, or 1 equals 1. Obviously 1 equals 1. This or, logical or, is breaking this SQL query. So now in our secure login, we go to the secure page. When I do admin and admin pass, it still works because that's the only password we have here. But if I try that or 1 equals 1 again, you can see it failed. Inject that. We use the question marks here.
To protect against web attacks, developers follow these practices: input validation and sanitization, parameterized queries to prevent SQL injection, output encoding or escaping, content security policy or CSP, the use of cross-site request forgery tokens, secure cookies, and HTTPS everywhere. Web attacks are extremely common and powerful, but they are often preventable. Understanding how they work helps us build safer websites. Security awareness is crucial for everyone, not just developers.